Maniac. Iman. Jujur, kalau di atas lah.
Orang tu orang sikit
Ada pakai kat sini. Suara perempuan ni.
No, I lost again. This ain't fair. Let's play game B, man.
Let's go.
No, we have already decided to play game C first, didn't we?
No game A or game C. Stop playing right now. Go do your homework.
Alright. Oh, Mom. Just one more round, please.
And how long will this round take?
It takes 10 minutes for game A, 8 minutes for game B, and 12 minutes for game C.
Wow, how do you know that, man?
By using inverse metric.
What is inverse metric, man?
Don't worry now. I will explain it to you. Okay. Hello everyone, this is Uma, and today we will find out how much time it takes for us to play one round of game A, B, and C respectively, based on the previous data. We have played 2 rounds of a game A, 1 round of game B, and another round of game C yesterday, and the total time it took was 40 minutes. This morning, we have played 1 round of game A, 3 rounds of game B, and 2 rounds of game C, which makes a total of 58 minutes. And just now, we have finished playing 3 rounds of game A, 2 rounds of game B, and 4 rounds of game C, and it took about 94 minutes in general. Taking this data in mind, we have this equation. Next, we will rewrite our equation into metric form. Hence, this is what it looks like. Let's say this is metric A, which consists of the coefficient of the variables in the equation, and this is metric X, which are the variable, and this is metric B, which are the total values in the equation. First thing first, we have to check whether the determinant of metric A is equal to 0 or not. If it does not equal to 0, that would mean AX equals to B. We also can say X is equal to A inverse B. If the determinant of the metric is equal to 0, that would mean inverse metric does not exist. So, how to find the determinant of metric A? It's pretty simple actually. So first, we will get rid of the first row and the first column of the metric A, leaving us with a 2 times 2 metric. Then, we will take 2 and it will be reduced to 2 times 2 metric, which look like this. Then, we will minus 1, which is in the first row, second column with 1, 2, 3, 4. And then plus 1, which is in the first row, third column with 1, 3, 3, 2. Just like finding the determinant of metric 2 times 2, we get the determinant of metric A equal to 2 times bracket 3 times 4 minus 2 times 2 close bracket. Then minus 1 times bracket 1 times 4 minus 2 times 3 close bracket plus 1 times bracket 1 times 2 minus 3 times 3 close bracket. We get the answer, which is 11. Hence, the determinant of metric A is not equal to 0 and the inverse metric exists. So, let's continue. Second step would be finding the A inverse by using adjoint method, which would be our highlight for today. We know that A inverse is equals to 1 over determinant of A times adjoint A. So there is two information that we need, which are the determinant of matrix A, which we have to find out earlier, and the adjoint matrix A, which is the transpose of the cofactor matrix. Now we have to find the cofactor matrix. First step of the finding the cofactor matrix would be by the determining the minor of each element in the matrix. Since A1 1 in matrix A is 2, which at the first row and the first column, the minor of the first element would be this. Repeating the same step with the rest of the element, we are left with this. Don't forget that this would be positive, negative, positive, negative, positive, negative, and positive, negative, positive. So 3 times 4 minus 2 times 2 is 8, which our C11, and then negative 1 times 4 minus 2 times 3 would be 2, which is our C12, and the rest calculation follow how we do in the first and the second example. Ta-da! This is our cofactor matrix A, but this is not adjoint A because we haven't transposed yet. How to transpose the cofactor matrix is pretty simple actually. You just need to rewrite the column to be the row respectively or vice versa. For example, first column will become first row, second column will become second row, and third column will become third row. Easy, isn't it? So now we have our adjoint A. To find the inverse of matrix A, let's recall back the equation earlier. A inverse is equal to 1 over determinant A times adjoint A. Substituting the determinant and the adjoint into the equation, the inverse of matrix A is equal to 1 over 11 times adjoint A. We get the inverse of the matrix A. Let's go back to our equation from the start. So X is equal to A inverse times B. First, substitute the inverse of the matrix and matrix B. Then inverse of matrix A times matrix B. And we finally get the answer. One round of game A takes 10 minutes, game B 8 minutes, and game C 12 minutes. Finish! Don't you understand?
Oh, I understand now.
Yeah, but we also can find the answer using the ERO method.
Oh, I know that method. But wouldn't it be more time consuming?
It kinda is, but it wouldn't hurt to learn. I will leave the explanation to another group.
Okay, only one round. And no playing after this. Did you hear me?
Aye, ma'am.
Itu.
By using inverse method. But it wouldn't hurt to learn. It kinda is.